in the speeds, we have the variations in the fuels used in the system, we have variations in the drive systems. So in the initial phases, we had the gearbox systems. So now we are moving to an upgraded system of changing the drive systems into a CVT engines, continuous variable transmissions engines, or you go for electric motor drive, where we use some special drive systems like harmonic drive systems, which is controlled by fully electronics. And this drive systems, these are the improvement with respect to the drive system. Similarly, you have the steering system, we have the electrical system, coolant system, fuel system, and brake systems. All these systems in integrated. Each R&D teams are working in this integrated system to make the development. So you take the drive system, not only in the drive system, the entire system is connected, and this is a complete mission. Whereas you degrade this everything and you break the systems, you can individually select the system. So each individual R&D teams or the engineers will be working to or the most performing system with the basic inputs what they have. Okay, so here you can see that the may the spring system, suspension system, which is used in the drive, where you have the steering mechanism, which is you connected by using some the hook joint, which is used in the steering universal joint. Okay, so all these mechanisms help us in making some practical application for our day-to-day life. So it is very important to know about this mechanism from the basics. So how we apply this basic concepts to the practical machines, or we make more sophisticated machines. We develop more sophisticated machines for the end users of the people, so that they are more convenient and sophisticated in their day-to-day life. Okay, so our major focus of this course will be in relative to the kinematic systems, which is being used in our day-to-day application. All of us have studied engineering mechanics from when we started our course, so curriculum of BTech. So engineering mechanics is the preliminary subject, where we will be studying about the mechanics of the rigid bodies, whereas we have the other bodies like deformable bodies and mechanics of studying in the solid mechanics and fluid mechanics. Whereas under rigid bodies, we have two types of motions. One is the static motion, and the other one is the dynamic motion, one which deals with the forces and effects which affect the rest of the body, but no variation with respect to the time. Whereas dynamic systems deals with and its effect while acting on the bodies which are in motion, so they have variations with respect to the time varying systems. Okay, so it is very important to design any system both in the static and the dynamic state, as we know that any applications we take that are in a dynamic systems. Okay, so in dynamic systems we have two types of systems that we have been using it. One is the kinetics and the kinematics. So whenever we design the system by taking into the effect of forces which is responsible for the system to come into play, that is the forces which makes the motion, we call that as the kinemic. Whereas in kinematics, we study doesn't take into account the forces, but responsible for the motions, where we take the where we consider the velocity, position, and acceleration, and the geometrical aspects of the motion for consideration of the forces. So this kinematics is very important to know, to design any mechanism, to design any system, so that the mechanism, how the path is defined, how the motion is defined, and what about the dimensions of the system. So finally, we will be doing synthesis of the system to develop the system into a real-time application. Okay, so the basic things, what we have I told here is kinematics deals with the study of the motion, like the position, velocity, acceleration, or and the geometrical aspects of the motion, without considering the portion which is without considering the forces which is making the motion. Okay, whereas kinematics in the deeper is referred to as a machining mechanism, which is a combination of interconnected rigid bodies capable of relative motion between the body. So when we have relative motion between the body, when we take that machine as a relative motion between the rigid link present in that, we consider that as a mechanism. Whereas if the relative motions are absent, we'll be taking it as a structure. Okay, So so here we have a connecting rod and then a piston, so which is the defined as the link or a member or a combination of a member which are connecting the members and having relative motion between them. So the diagram shown here in the engine, we see the piston, rod, engine frame, and the crankshaft where the links are being made to connect it. So you can see that these are kinematic links or element which is used to create the mechanism. Okay, so in creating the mechanism, we should be making some rigid bodies to create the mechanism, but the rigid body should be having a relative motion among the mechanism. So we every cases we take the applications of the engines, so which is the most referred example. So we here you can see that the piston cylinder and there's a crankshaft between the piston cylinder and the connecting rod, okay, which is connecting it as a slider crank mechanism. So this like one of the rotary motion is getting converted into a linear translated motion. Here the linear input is converted into a rotary motion. So you see that here in the mechanism some power transformation of the energy systems is there. So mechanical energy is converted into other forms of energy, or we use the heat and the heat energy we to convert into the mechanical energy to make it as a useful work. So always we design the systems